Welcome back to Mr. DuPage's classroom. This lesson is for my General Algebra 2 class. It is solving quadratic equations by graphing. Let's get right into the notes. When graphed, the solution to a quadratic function are the x-intercepts. X-intercepts are where our graph will cross the x-axis. Okay? Here are our steps in order to find our x-intercepts and to graph these problems. As you'll notice, all of these problems are in standard form. So if you remember standard form from our last couple of units, then you will understand what we are doing. The first step is to make the equation equal to 0. If you look at example 1 right now, I have x squared minus 4x equals 5. I want to make that x squared minus 4x minus 5 would equal 0. The second step is to use the formula x is equal to negative 1 times b, or the opposite of b, over 2a. This is exactly the same thing we did in our last unit when we worked with standard form. So we're going to use that formula to find the axis of symmetry. Then we're going to substitute that x in to find our y. Then we're going to go ahead and make our table, putting the vertex in the middle just like always. Using the pattern to fill, all we have done in the past is we just substitute each one of those numbers in for x and solve for y. Finally, we're going to graph, and then we will find our x-intercepts. So let's go ahead and go through a problem. Like I said, we do not want this to be equal to anything but 0. So in order to make this equal to 0, I need to subtract 5 from both sides. So my equation would be x squared minus 4x minus 5 is equal to 0. That's what we're looking for. We've always seen it as y equals our equation. Okay. Now, in our previous unit, we found our a value, which in this case would be 1, our b would be negative 4, and our c would be negative 5. Again, that's reviewed from the previous unit. Step 2 is to go ahead and use our formula x equals the opposite of b over 2 times a. So I'm going to go ahead and plug in my b and a values. So it'll be negative times negative 4 over 2 times 1. Negative 1 basically times negative 4 would get me positive 4. 2 times 1 would get me 1. So 4 divided by 2 would be 2. Now I need to go ahead and plug that 2 back in the equation to find my y. So y would equal, I'm going to look at this equation right here. Everywhere I have an x, go ahead and make a parenthesis like we have done in the past. Plug 2 in the parentheses. Go ahead and type that straight through in your calculator. And you end up with negative 9. So my vertex is 2, negative 9. Okay. The next step is to go ahead and make a table. Whenever I make a table, my vertex always goes in the center, so go ahead and do that. Fill in our x's by adding 1, subtracting 1, just like our previous unit. Okay. Now I'm going to go ahead and put 3 in for my x's, type that through in our calculator just like before. I would end up with negative 8. If I put 4 in for the x's, I'd have negative 5. We can go ahead and fill in the rest of our table. Now this is where we're going to get a little bit different. Everything so far has been exactly what we did in our previous unit. Now what I need to do though is to find what x will make my y equal to 0. That will tell me what my x-intercepts are. So I'm going to go ahead and add one more number and subtract one more number to see if those will equal 0. So I'm going to take 5, plug it in for my x's. So it would be 5 squared minus 4 times 5 minus 5. Go ahead and type that into your calculator quickly, see what you get, and then I will tell you what I got. Shouldn't take you more than about 30 seconds, so go ahead and try that. Alright, after you are done, what you should have gotten is 0. That is what we are looking for. We want our y values to equal 0. Just like in our previous unit, if the 5 is 0, then that negative 1 would also be 0. Okay? So now we have found our x-intercepts. What I can do is I can write x-intercept it would be 5 from here, comma 0, and it would be negative 1 from there, comma 0. All right, we'll talk about how we're going to write our answer here in 1 second. What I want to do is to go ahead and graph this now. So I would go to 2, negative 9. I'd go to 3, negative 8. 1, negative 8. 4, negative 5. 0, negative 5. And 5, 0, negative 1, 0. We want to connect all of our points. If you remember from the previous unit, I would go ahead and make a vertical dotted line here. You don't have to at this point, but it would be good practice considering you will have a final at the end of the semester that you're going to have to remember that for. Okay? Now to write my answers. My answers are these points on the graph right here that cross the x-axis. Those are also known as my x-intercepts. Okay? If those are my x-intercepts, then I would write x equals, it would be negative 1 and 5. Those are my answers. It just comes from that negative 1 and that 5. Okay? Let's go ahead and do number 2 then. First step is to always get our equation equal 0, so it'll be negative 4x squared minus 8x. If I wanted to make this 0, I would add 12 to both sides. So plus 12, that would equal 0. Remember, this would just be our y value. Okay. So our a at this point is negative 4. Our b is negative, Our b would be negative 8. Our c would be 12. To find my x, it would be negative 1 times my b value over 2 times my a value. Well, my b value is negative 8, so it would be negative 1 times negative 8. 2 times negative 4. That would get me positive 8 over negative 8. 8 divided by negative 8 would be negative 1. To find my y, I would go ahead and just put negative 1 in for all of my x's. When you type that through into your calculator, you would end up with positive 16. If you are still struggling with those steps, you need to come in before and see me because those are all review. We have gone over this numerous times, and you really need to be able to find your vertex. Okay? Also, you should be able to fill out a table as well. My vertex goes in the center, add 1, subtract 1, subtract 1. If I put 0 in for x, I would end up with 12. If I put 1 in for x, I'd get 0, 12, 0. Okay, hopefully you know how to do that as well. As you notice, what did I say we are looking for in our table from that first example? We are looking for our y values to be 0. That will tell us where our x-intercepts are. So my x-intercept would be 1, 0, and negative 3, 0. Okay? We need to go ahead and graph this. So I would go to negative 1, positive 16. I would go to 0, 12. I would go to 1, 0, which means I'd have negative 1, 12, or negative 2, 12, I'm sorry, and negative 3, 0. And there's our graph. Remember that this is our axis of symmetry, or the x value I found earlier. All right, now what do I do to write my answer? I'm just going to use the x from here and the x from here. So it would be x equals negative 3, 1. All right. Moving on to the back side. We're going to treat this, even though it's not an equal sign, we have a greater than sign, or you could have a less than sign, you could have a greater than or equal to, less than or equal to. Even though it's not an equal sign, we're going to treat this exactly the same way. Okay? Right now, that isn't a form that we're used to seeing, so I can just say that my a value is 2, my b value is 4, my c value is negative 6. All of the initial steps are going to be exactly the same. There's only one one difference here at the end, and I will explain that here in a second. So our next step would be to find our x value. So it'd be -1 times my b over 2 times my a. My b is 4, so it's -1 times 4. 2 times 2. So it'd be -4 over 4, which would be -1. To find my y, I'm going to take -1 and plug it back in my equation. So it'd be 2 times -1 squared plus 4 times -1 minus 6. If you type that into your calculator, you'll end up with -8. You should be able to do that without a calculator, but I do allow you to use them. So my vertex then would be -1, -8. And now we would create our table. -1, -8 goes in the center. Add 1, so 0, 1. Subtract 1, subtract 1, so -2, -3. If I put 0 back into my equation, I would have -6. If I put 1 back in, it would be 0, so -6 and 0. Again, I'm looking for where my y values are 0. So that would be right here at -3 and right here at 1. So my x-intercepts would be -3, 0, and 1, 0. All right? I'm still going to go ahead and graph this. So everything that we've done so far is exactly the same. So I would go to -1, -8. I would go to 0, -6, and -2, -6. Then I would go to 1, 0, -3, 0. Now, this is where things change a little bit. Okay? What I'm looking at is this inequality sign. Right now, it's just a greater than sign. You have greater than, and you have greater than or equal to. You also have less than or less than and equal to. If it's just the greater than sign, so there's no bar underneath, what we are going to do is turn this into a dashed line. I'll explain why in 1 second. But our graph would be a dashed line. Okay? If it was greater than or equal to, which would be that guy, that has a solid line underneath, right? So that is telling you, hey, look, go ahead and use a solid line. So since it is an inequality, what this means is everything that is greater than my graph is a possible answer. So inside of my graph, it would be everything that is above the line. That's above the line. That's above the line. That's above the line. Everything inside of here is above the line. So I would go ahead and shade everything inside of my graph. So if it was less than, it would be everything that is outside my graph. If it was greater than or equal to, it would still be everything inside my graph. If it was less than or equal to, it would still be everything outside my graph. Okay? If you do not understand that, make sure you ask a question tomorrow. So in order to graph inequalities with solid lines, it would need to be greater than or equal to, or less than or equal to. With dashed lines, it would just be greater than or less than. To shade up, like we did in the previous equation, it would be greater than or equal to, or just greater than. And in order to shade down, which we did not see an example of, would be less than or equal to, or just less than. So basically what we just learned is that we are going to treat this just like a standard form equation and how we graph those. However, our answers are going to be our x-intercepts when it has an equal sign. When it does not have an equal sign, that is the inequalities that we talked about on the back page, and that is our lesson for the day. If you have any questions, please make sure you ask tomorrow. Don't ever sit around and just be confused. Either come in before school or get my attention during class, and I will help you. Thank you very much for watching the video, and have a great day.